Okay, here's some help on our polynomial function review sheet. And we're going to look at all the important things you need to know about. And the big terms that we're going to work on we'll highlight at the end, but everything that you need is in here. Polynomial functions are combinations of coefficients and exponents. This function is not in standard form. Why? Because it doesn't go from biggest exponent. All right, not. So it's not from biggest exponent to smallest exponent. And I've written it out in there. I know my 1 is falling off the page, but it's still good. As a matter of fact, this function is, the degree of a function is the value of its biggest exponent. So this function is a 7th degree equation. As I can look at these right here and state the degree of the following. This one is 9th. This one is 3rd. And this one is 1st. Correct? No, no, no. You can't just look at the first term, goofy goobers. You got to make sure you check all the possible ones. This is a 9th degree. This one is a 5th degree. And this one is a 7th degree. Whew, glad I saw that while I was doing it. Now, some degrees have special words that go with them. 5th degree is known as a quintic function. So that's a T. 4th degree is known as a quartic, like a quart of milk. A 3rd degree is known as a cubic. 2nd degree is known as a quadratic. A 1st degree is a function that has no turning points. It is a linear. And a 0th degree is known as a constant function. They look like this. They have no change in height. That's why they're known as constants. Now, extreme points, which are also known as turning points, they tell you the degree of the function. The degree of the function is always one more than the number of turning points. If you're not sure on that one, draw yourself a quadratic. It has one turning point, and this is a 2nd degree. Here's a linear. This is a linear function right here. It's a 1st degree, and it has 0 turning points. So the function that's right here has 2 extreme points, so it is a 3rd degree function. Who dat? Who dat? Odd or even degrees have different looks. How can you tell? Our even degree functions are going to go all the way up in both directions or all the way down in both directions. And the odd degree functions are going to have arms in different direction. So even or odd determines whether the ends match and go in the same direction or are different. And the leading coefficient is just Cal. Put Cal in the race. He'll be in the front. So whatever happens in the front determines what happens as x gets bigger. So that because this is a negative leading coefficient, the graph is going to go down. The zeros of a function are the values, oops, sorry about that, that make the function equal to 0. There are real zeros, and there are non-real. There are real zeros you can see, and non-reals you can't. The number of zeros is the same as the degree. That's what Des Bryant tells us. Degree equals zeros. So I've got my first graph right here. Well, not my first graph. I have one of my graphs. It has 1, 2, 3, 4 turning points. That makes it a 5th degree function. In terms of it means it has 5 zeros. I can see 3 real zeros. And as a matter of fact, I can also see that there are, because there's 3 real zeros, there has to be 2 non-real zeros. And they always come in pairs. They come in what are called conjugate pairs. J-U-G-A-T-E pairs. As a matter of fact, if I know one of the zeros, if it's like 2 plus 3i, then I know the other one is 2 minus 3i. That's always the case. They always work out that way. This function has a positive leading coefficient. There's Cal. It goes up. And it has no global max or min. Sometimes you will have special double zeros. A double zero, it touches the axis just once. But it counts as 2 zeros. It's like a 0 going down, a 0 going up. Okay, so let's take a look at my graphs right here. I'm looking really quick. I know this is even because of the way the arms go. I know this is odd because of the way the arms go in different directions. I know I'm going to do it in a different order than I necessarily have written down. I'm just looking here to tell me that the leading coefficient of this one is negative. And for this one, the leading coefficient of the function is positive. I know it's out of order. So let's find our degrees. 1, 2, 3, 4, 5. Sixth degree. 1, 2, 3, 4 is a fifth degree. And that matches up with what I said about being even or odd. This means it has 5 turning points. Means there's 6 zeros in total. 1, 2, 3, 4, 5, 6 are real. That's a double zero. 2 are non-real, and this one has a max. On the next function, it's fifth degree, so there's 4 turning points. That means it has 5 zeros. It has 1, 2, 3, 4 reals. That means it has 1 number. Oh, wait a minute, that can't be true. Those non-real zeros have to come in pairs. Let's take a look back. I see 1. Oh, I didn't notice that. 2. This is a double. 3, 4, 5. Whew. It says 5 reals. That's 5. 0 non-reals. And it does not have a max or min because it goes off in 2 different directions. So once again, those are the features we need to look for. And down here I ask us to graph a couple here. Sketch a cubic function with 2 negative zeros. I'm going to mark them. A positive 0 and a negative leading coefficient. That tells me as this graph goes on, it's going to go down. So what I'm going to do is I'm just going to make my way through those points. It's a cubic function. It meets those conditions. Sketch a function with an even degree and a global max. It means it has to have a high point somewhere. I'm going to pick a high point and put it there. And I know that an even function, all it needs to do is have them both go up or go down. Sketch an odd function with a double 0 and a leading coefficient, a positive leading coefficient. So I'm going to give it a double 0 right there. I know it's going to be going up, so I'm going to make that a double 0. And then it doesn't matter how many swoopy doopies I do, I just have to make sure in the end, because it's odd, it goes in the opposite direction. So there's all the pieces of the review sheet. This part I just added in today, but we're going to talk about it tomorrow. And hope this helps. I'll see you in class tomorrow.